Today we're going to go over problem 4 on the 2019 AP Calculus AB FRQ. So let's get right into it. So problem 4 says a cylindrical barrel with a diameter of 2 feet contains collected rainwater as shown in the figure above. The water drains out through a valve not shown at the bottom of the barrel. The rate of change of height h of the water in the barrel with respect to time t is modeled by dh dt is equal to -1/10 square root h, where h is measured in feet and t is measured in seconds. And the volume V of a cylinder with radius r and height h is V is equal to pi r squared h. Okay, so part A says to find the rate of change of the volume of water in the barrel with respect to time when the height of the water is 4 feet. And it tells us to indicate our units of measure. So what stands out in this problem is that when it says find the rate of change when the height is 4 feet, I immediately know it's related rates because we're just finding the rate of change at this specific time. So I'm going to put out a formula. V is equal to pi r squared h, because this is the volume of the cylinder. So when solving these problems, first I like to put out my givens. So we know that our height is 4 feet because it's just in the problem. And then we know that our radius has to be half the diameter, which is 2 feet. So it's just going to be 1 foot. And then we have dht, which is -1/10 square root of h. So we'll put that down. dht is equal to -1/10 root h. Okay, so to solve this problem, we have to take the derivative of this formula. So that's just going to be dv dt is equal to pi. And also one thing I wanted to point out, this r, actually I want to plug in my 1 to this r first. So let me do that. So if it's just r squared or 1 squared, it's just going to be 1 and it's just going to cancel out. So we could just get rid of this. So we just have pi, the derivative of pi h. So that's just going to be pi. H is going to be just 1, so it's going to cancel out. And then we have dh dt. Okay, so we have our givens, so we want to plug in dh dt, which is -1/10 root h. So that's just going to be pi multiplied by -1/10, and then our height is 4, so that's just going to be the square root of 4, which is 2. So if we simplify this, our final answer, dv dt, is just going to be -2/10 or -1/5 times pi, which is -pi/5. And then it tells us to indicate our units of measure. So it's going to be feet cubed because it's volume over a unit of time, which is seconds. So our final answer is -pi/5 feet cubed per second. Okay, so part B says when the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? And explain your reasoning. So for this problem, we want to take the derivative of this function, dht is equal to -1/10 square root of h. And then this is because it'll find whether it's increasing or decreasing, depending if it's either positive or negative. So we're going to take the derivative of this. dht is equal to -1/10 h. So this is just going to be d2h dt squared is equal to, and then the derivative of this, we could use the power rule. This is h to the 1/2, so we're going to move the 1/2 to the front. So that's just going to be -1/10 or times 1/2, -1/20 times h to the -1/2. And then h to the -1/2 is going to go to the bottom here, which is just going to be square root of h. And then we also can't forget our dh dt because it's implicit differentiation. Okay, so I kind of want to clean all this up. So since we already know dHdt from this problem, we can plug that in. So I'm going to go up here. And then dHdt is just going to be negative 1 over 10 times square root of h. Okay, so now we could just plug in our value, which is for height, which is 3 feet. So let me just write this down. H is 3. So we're going to plug this in, and this is just going to be equal to negative 1 over 20 square root of 3, and then times negative 1 over 10. So times, and it's times square root of 3. Well, let me write square root of 3 up here. So since this is being multiplied, this just cancels out our square root of 3. So it's just going to be negative 1 over 20 times negative 1 over 10. So we multiply our denominators, and it's just going to be a negative 1 over 200, and we also cancel out our negatives because negative times negative is positive. So our answer is just going to be 1 over 200. All right, so now we know that 1 over 200 is greater than 0. And because the derivative of this function is greater than 0, that means that the height of the water at 3 feet is going to be increasing. So I'm going to write increases, or inc for short. And that's our final answer for part B. All right, so part C says, at time t is equal to 0 seconds, the height of the water is 5 feet. Use separation of variables to find an expression for h in terms of t. So this problem is telling us to use this formula, dHdt is equal to negative 1 over 10 square root of h. And we want to separate our variables, so put the t's and the h's on one side and integrate to find our answer. So let me write out the formula, dh dt is equal to negative 1 over 10 root h. So we want to move our h's and our t's to one side. So square root of h, if we move this to this side, it just becomes 1 over root h. dH, sorry, is equal to negative 1 over 10. And then we move our dt, so we put this dt on this side. So it's just going to be dt. So to eliminate this dh and dt, we're just going to take the integral of both sides. And this is the indefinite integral. So here we could just rewrite 1 over square root of h as h negative 1/2. And then to integrate this, we could just use the power rule. So we add plus 1, and then we have negative 1 over 2 plus 1. And then this is going to simplify to h to 1/2 times 2. So we have 2h to 1/2. And then when we do a definite integral, we want to add our constant of integration. So our constant is just going to be labeled c. And then if we integrate this is an easy integral. We just want to slap a t to this constant. So it's going to be negative 1 over 10 t. And then we want to add our constant of integration. So that's just plus c. So something we could actually do with this constant is that we could take one of them out, because an arbitrary constant minus an arbitrary constant is just going to be another arbitrary constant. So we could rewrite this as 2h to 1/2 is equal to negative 1 over 10 t plus c. All right, so in order to solve this, we actually want to find the value of c. So I'm going to move up here. 2h to 1/2 is equal to negative 1 over 10 t plus c. So for this, we want to plug in our givens. Our height is just going to be 5 feet, so h is 5. And then our time is 0, so t is equal to 0. So if we plug all these into this equation, this is just going to be 2 times h to 1/2, or just square root of h, and h is 5. So 2 square root of 5 is equal to negative 1 over 10 times 0, just 0. So, and then we're going to have just plus c. So since this just cancels out, it's just going to be c is equal to 2 times the square root of 5. Alright, so now we can rewrite our equation. 2h to 1/2 is equal to negative 1 over 10 times t plus 2 times the square root of 5. So we want to set our h in terms of t. So to do that, we have to move everything to the other side and just leave h alone. So to do this, we could divide both sides by 2. h to 1/2 is equal to negative 1 over 10t divided by 2 is just going to be negative 1 over 20t. And then 2 times the square root of 5 divided by 2 is just going to be square root of 5. Alright, so now we want to get rid of this 1/2. So to do this, we could just raise everything to the second power. So if we raise this to the second power and this to the second power, this is just going to be h is equal to negative 1 over 20 t plus square root of 5 raised to the second power. And then h in terms of t, we could just write this as h of t is equal to negative 1 over 20 plus square root of 5, and then everything is just squared. And this is our final answer for part C. Alright, so thank you. Like and subscribe if you enjoy the video, and have a good day.